I'm going to connect this LED without a resistor in series. You will observe what will happen to it. So let me connect. So I've connected the LED. Let me turn on the power. So you see it just light up and it went off. So let's observe the second LED. The first LED is here. Let's observe the second LED. So you have seen that after connecting after a resistor, this LED is lighting constant. The first one lighted and blew up. So the reason why the first resistor lighted and went off, that is because that LED is blew up. But the reason why this second one is still lighting, this is because this LED did not blow up, so it's still working. So today we are going to discuss something about current limit resistor. We're going to discuss why the first LED lighted up and went off, but the second LED still on. Current limit resistor. So this is the symbol for a resistor. What's a current limit resistor? A current limit resistor is a resistor placed in series with a circuit component to restrict amount of current flowing through it, and it prevents excessive current that could damage components like LEDs, transistors, or integrated circuits. The significance of a current limit resistor, it protects components. This prevents excessive current to flow through the circuits that could burn out components like sensors, integrated circuit ICs, LEDs. It controls power dissipation. This helps to manage heat and prevent overloading. It ensures proper operation. Some components require a specific amount of current to function correctly. So that is the reason why we use a current limit resistor. The reason why the first LED blew up, that is because the current was more than its rated current. The reason why the second LED didn't blow up, that is because it received its required current. So the supply is providing more current than the LED rated current. So for us to be able to manage that, so that we don't damage the components, that is why we need to connect a resistor in series with LED, which is called a current limit resistor. So this resistor is going to give the maximum current required for the LED. If you don't put any resistor in series, that LED is going to blow up, as we saw when we started. So how do you calculate this value of resistor? So this is the schematic diagram how to connect a current limit resistor. It's always connected in series with the components is going to protect. Like in this case, the resistor is here. Then the component is going to protect is this LED. Okay. So the supply voltage, you can see the supply voltage is 5 volt, 1 amp. That is what the source provide. Then the LED is rated 3 volt, 40 milliamps. This is like 0.04 amps. Okay, you see the amperage is very high. So if you connect this LED directly without a resistor, that's the reason why the first LED blew up. But when you connect a current limit resistor in series with this LED, this resistor is going to protect this LED. This resistor is going to dissipate some of the power from the source into heat and provides the required current for the LED. Design in how do you calculate the value of the resistor? Now that we have this one, is unknown, but we want to power this LED having this specification. How do you calculate the value of this resistor? There are some important parameters you have to consider. First of all is the voltage source or voltage supply. Voltage source. You have to know the voltage source, like in our case is 5 volt. You have to know the voltage required by the load voltage. In other words, VL, which is load voltage required by the load voltage required by the load, or load voltage. Then the last one, you have to know the load current, IL. So these are the parameters you have to take into consideration when you calculating the value of the current limit resistor. This is method 1. We are also going to do method 2. So the formula to calculate, can write here formula to calculate the current limit resistor. In method 1, we are going to use this formula. Resistor is equal to voltage supply minus the load voltage over the load current. Okay, so this is the main formula. Now let's substitute our values from the circuit. The supply voltage Vs, okay, so resistor is equal to supply voltage Vs, which is 5 volt, minus the load voltage. You can see here the load voltage, which is 3 volt, over the load current. So it is 0.04. So this is going to give us the output, or the required resistor value. So when you calculate this, 5 minus 3 over 0.04, this gives us around 50 ohms. So you'll have to look for a 50 ohm resistor. This is the resistor you're going to put to connect in series with the LED. Now, there is something else very important you have to understand. You have to calculate the power dissipation. So power dissipation is equal to, power in DC circuit is equal to voltage times current, or power dissipation is equal to current squared R. So the current is 0.04, the resistor is 50. So let's calculate. So the power dissipation is equal to 0.08 watt. Okay, so a normal resistor is rated a quarter watt. Okay, so the reason why we calculate this, because you might calculate and you find that the wattage is 1 watt, 2 watts, 3 and above, depending on the supply source. Because if you have 10 volt, it will not be the same. So you have to calculate the wattage. Let's say you get 50 ohms, 2 watts. So you go in the market, you look for a 50 ohms, 2 watts resistor. That is what will sustain your circuit. So guys, that's the brief we can say about the current limit resistors. So guys, this is method 1. Let's meet on next time on method 2.